So having done moment of inertia of standard objects, I want to talk about uh, two theorems that will help us to find moment of inertia of an object about different axes without the complicated integrations involved. So this will help us get rid of the complicated integrals. So, supposing that we have a three-dimensional axis and we have a lump of an object. There's a three-dimensional lump of an object, and harsh. And supposing that I want to find the moment of inertia of this object about, let's say, the y-axis, the vertical axis. So let me call this axis OO dash. So what do I do? Well, I will choose an element and I will find the perpendicular distance of this element from the OO dash axis. Just out of curiosity, if the x, y, z coordinates of the element are known, supposing, then can you tell me what is the perpendicular distance of this element from the z-axis? What will be the perpendicular distance of this element from the, sorry, not from the z, from the y-axis? Yeah. So let's say that this is the x-axis, this is the y-axis, and this is the z-axis. I want the perpendicular distance of element whose coordinates are x, y, z from the y-axis. What is the perpendicular distance of the element from the y-axis? क्या होएगा ये? What will be this? नहीं, Tulika, because if you say that the answer is x, then this is x, right? This is x. This is not the perpendicular distance of the object from the y-axis. What is the perpendicular distance of the object from the y-axis? Yes, Mitesh, that is the correct answer. So we have x, we have z, we have y. Perpendicular distance from the y-axis will be this side, will be this distance, and this distance will be equal to under root of x square plus z square. Is this okay? Is this understood by everyone? हाँ या ना बताओ, नहीं तो फिर मैं दूसरा डायग्राम बनाऊंगा. I O dash will be dm x square plus y square x square plus z square, and this is di. So I O dash will be equal to summation of mi x square plus z square. ठीक है क्या? Now supposing that this axis is passing through the center of, or let's not worry about the center of mass at the moment. Now supposing that I wish to calculate the moment of inertia of the same object from this axis. Now this axis is parallel to OO dash. That is not that is given to me, and it is hitting the XZ plane somewhere here, right? So the distance between the two axes is, let's say, given as h. The distance between the two axes is given as h, and let this axis be AA dash. So what will be the moment of inertia of the object about AA dash? Will be dm multiplied by the perpendicular distance whole square. What will be the perpendicular distance of this guy with this axis? What will be this distance? Given that the distance between the two parallel axes is h, what will be the perpendicular distance of the chosen element from the axis AA dash? I hope my diagram is clear. I hope my diagram is clear. क्या होएगा? So in the same diagram, I don't want sine theta or cos theta right now. In this diagram, this distance is given as h. Very good. Yes. 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 लेकिन बट नहीं यार, ये गलत है आंसर थोड़ा सा. Would it be of further help if I told you, I don't know, if I told you that the, let's see if it would be further helpful or not. If I told you the x and z coordinates of the point where the OO dash axis cuts the XZ plane. So supposing that I tell you that this is Z naught and this is X naught, then can you tell me the perpendicular distance? Of course, X naught square plus Z naught square is equal to X square. That is given to us. Now can you tell me the perpendicular distance? So basically, if you are looking at the thing from the top, if you are looking from the top, बिल्कुल सर्कल तो नहीं दिखाई देगा ऑब्जेक्ट, ठीक है. This is the AA dash axis. The element is somewhere here. Okay. Sorry, मैंने एक्सिस को उल्टा कर दिया. हाँ बिल्कुल डिस्टेंस फार्मूला यूज करना है ना, तो वही इसीलिए मैं 2 डायमेंशन में बनाना चाह रहा हूँ. So this is the x axis and this is the z axis, right? Yeah. So the x coordinate of this guy is x and the z coordinate of this guy is z, and therefore the perpendicular distance of this guy from this point, from this axis which is coming out of the plane, is equal to under root of x square plus z square, right? This is how we got under root of x square plus z square. Now what I'm saying is that there is another axis, and this axis is somewhere here, let's say, and I'm telling you that look, this is x naught and this is z naught, and I want you to find this distance. अभी समझ में आ रहा है क्या करना है? ये दिखाई दे रहा है? अगर हम केवल 2 डायमेंशन की ही बात करें, let's say that we forget about the y-axis and we can forget about the y-axis because we are finding the moment of inertia with respect to y-axis. So we are only interested in the perpendicular distance from the y-axis. क्या होएगा? बताइए. Now this should be easy, right? The coordinates of this point are x comma z. Coordinates of this point are x naught comma z naught, and I'm asking you for the distance between these two coordinates. So what should this distance be? This distance should be how much? बताओ भाई, सब लोग सो गए? कितना डिस्टेंस होएगा ये? हाँ, एग्जैक्टली तो यस. सीधा डिस्टेंस फॉर्मूला अप्लाई करते हैं. डिस्टेंस फॉर्मूला अप्लाई करेंगे तो x माइनस एक्स नॉट होल स्क्वायर, हाँ x माइनस एक्स नॉट होल स्क्वायर प्लस z माइनस z नॉट होल स्क्वायर under root. This may not be as obvious in this diagram. I'm sorry about that. But here, this is definitely going to be equal to x minus x naught whole square plus z minus z naught whole square, and the moment of inertia about the axis a dash is going to be summation of mi x minus x naught whole square, in fact xi minus x naught whole square, sorry, मैं थोड़ा जल्दी चल रहा हूँ, मैं स्टेप्स खाने की कोशिश कर रहा हूँ, plus zi minus z naught square, right? And of course the upper one is also xi and zi. Okay, so now let's expand this iaa dash. So if I expand this iaa dash, I'll get summation of mix. हाँ आएगा ना, अभी आएगा xi square plus yi square plus, मैं बस टर्म्स को सेपरेट कर दे रहा हूँ, summation of mi square x mi into x naught square plus y naught square minus summation of twice mi x naught xi, right? Uh, minus twice mi summation of y naught कहाँ से लिख दिया मैंने, z naught.
फिर ऊपर भी yi और y naught.
y लिख दिया क्या मैंने? मुझे ही नींद आ रही लग रहा है. So this will be zi. This will be. अब दिखाई दे रहा है कि ये h square कहाँ आएगा? दिखाई दे रहा है आपकी दीक्षा अभी? Can you see where I am getting? H square?
X naught square plus z naught square.
X naught square plus Z naught square.
So I'll just space खत्म हो रही है, तो I'll write it here. iaa dash is equal to, ये वाला जो टर्म है ये तो यही है. This is the same. So I will write I dash, yeah, plus, जब मैं इसमें समेशन करूंगा तो ये तो कांस्टेंट हो गया, तो x स्क्वायर हो गया, basically summation of mi आया, and I know that summation of mi is nothing but m, right? So summation of mi, if nothing, if it is nothing but m, so I just write it as capital M into h square माइनस, अब यहाँ पे कांस्टेंट्स बाहर निकाल देता हूँ मैं, ट्वाइस एक्स नॉट समेशन एम आई एक्स आई माइनस ट्वाइस जेड नॉट समेशन एम आई जेड आई. Okay, will all of you agree with this? I'll just go through it very quickly. We have taken a three-dimensional object and we have drawn the xyz axis, and about a particular y-axis called OO dash, we are trying to find the moment of inertia. We know that the moment of inertia is summation of mass multiplied by perpendicular distance whole square. So since we are trying to find the moment of inertia about the axis O dash, which happens to be the y-axis, I could have taken any axis, कोई फर्क नहीं पड़ता. I could have taken an arbitrary axis as well. So if I have taken the y-axis about which to find moment of inertia, we find that the perpendicular distance of the point object from the axis of rotation is under root of x square plus z square. Therefore, I have found the moment of inertia about the axis O dash, which is summation of mi, which is the mass of the ith element in brackets xi square plus zi square, where xi and zi are the x and z coordinates of the ith element. And now what I do is I say that, let's say that I want to find the moment of inertia about another axis AA dash, okay, and then I draw the axis AA dash such that looking at the situation from the top, the axis AA dash is having coordinates x naught comma z naught, where it is cutting the xz plane of the original coordinate axis. If this is so, then the perpendicular distance of the same element from this new axis AA dash will be equal to the length of the green line, which is shown by the yellow arrow, and the length of the green line is simply found by the distance formula. Okay. Now, please don't worry about the word perpendicular because of the fact that the axis of rotation are out of the plane of the slide that you are looking at. Therefore, any point drawn on the slide must, if it is joined with the point x naught z naught, automatically that becomes the perpendicular distance of that point from the axis AA dash. Okay, I cannot draw the 90 degrees right now because the 90 degrees is between the line which is coming outside of the slide, outside of the plane of your device, with the green line which has been marked with the yellow arrow. Okay, and so the distance between them, the perpendicular distance between the element and the new axis AA dash is root of x minus x naught square plus z minus z naught square. Therefore, I say that the moment of inertia about the axis AA dash will be equal to dm multiplied by this distance whole square, and therefore the net moment of inertia would simply be the summation of this. When I expand the individual terms in this expression, I find that one of the terms is nothing but the moment of inertia about OO dash, and the other term is nothing but m into h square, where h is the distance between the two parallel axes. Uh, it is nothing but under root of x naught square plus z naught square, that is h. Okay, minus 2x naught summation mixi minus 2z naught summation mizi. Okay, now it would be wonderful. It would be absolutely wonderful if the last two terms disappeared. Because if the last two terms disappeared, I would end up with a very, very simple and a very, very nice equation that would be that The moment of inertia about the axis A dash is equal to the moment of inertia of the object about the axis O dash plus mh square, where h is the distance between the two axes. Now, can you think of a condition where the last two terms would become zero? Think. xi and zi are constant. नहीं, बिल्कुल नहीं. xi और zi अगर constant है तो नहीं, mi should be really small. No, this is not. My question is that the moment of inertia that we have written down about the axis A dash contains four terms, out of which the first two terms are very nice and neat and easy, but the last two terms are very weird and I don't like them. So can you think of a condition, and you can, we have already studied this, can you think of a condition where the last two terms would become zero? नहीं बच्चा, mi xi is constant से zero नहीं होएगा. नहीं, point particle नहीं है ये. I am telling you that it is a three dimension. It is a three. We are studying rigid body dynamics now. We are studying rigid body dynamics now. Resultant is zero. That is what I want. That is what I want. X0 and Z0 are very small. No, they are not small. No. Can you think? Very good. Parth ने निकाल दिया. Good, good, very good. Yes, Pratiksha. Yes, yes, yes. Good, good. हाँ. So the condition is very simple. Where have you seen summation mixi before? Well, summation mixi we saw in center of mass. Center of mass is given by summation, x coordinate of center of mass is given by summation mixi divided by summation mi, right? And if the center of mass is having an x coordinate of 0, then obviously summation mixi will be equal to 0. If the z coordinate of the center of mass is 0, then again summation of mizi will be 0. So basically now what we say, okay, I'm going to go to a new slide. Basically now what we say is that if and only if, I just wanted you to work out the condition so that you never forget. If and only if the center of mass of the object lies on the axis OO dash, okay, x coordinate of center of mass will be equal to 0, which will imply that summation mixi will be 0. And the z coordinate of center of mass will be 0, which will imply summation of mizi equal to 0. Therefore, I dash will be equal to IO dash. Sorry, IO dash plus mh square. So I would like to write this like so. IAA dash is equal to ICOM. That means moment of inertia of the object about an axis passing through center of mass plus mh square. This in physics is called parallel axis theorem. So please write this down. Just to remind you, why is it? Why have I written ICM? This is just to remind you that uh, the axis O dash must pass through the origin, must pass through the क्या बोलते हैं center of mass. हाँ हाँ क्या रिपीट करना है मुझे? Why ICM? ICM Pratiksha, because we just need to remind ourselves that the axis OO dash is the the moment of inertia IO dash is the moment of inertia about an axis passing through center of mass. After all, अगर ये दो कंडीशन सेटिस्फाइड नहीं होंगी तो ये भी नहीं सेटिस्फाई होएगा, और अगर ये नहीं सेटिस्फाई होएगा तो जो मोमेंट ऑफ इनर्शिया है उसमें ये टर्म भी आएगा, ये टर्म भी आएगा, है ना? सो आई सीएम जो मैंने लिखा है, that is just to remind ourselves that the moment of inertia about this axis should be such that this axis should be such that it passes through center of mass.
बट फिर इसका आई ओ ओ डैश से कोई रिलेशन नहीं है ना?
नहीं है ना, आई ओ डैश ही है वो. So this can be any axis passing through center of mass. So I can have this three-dimensional object, and I can say that look, this is the center of mass. Okay, so now I can have this axis as OO dash, this axis as OO dash, and this axis as AA dash. Okay, and I can write I AA dash is equal to I OO dash plus MH1 square, where this distance is H1. Simultaneously, I can have this axis as OO dash and this axis as AA dash and this distance as H2, and again I can write AA dash is equal to I about OO dash plus MH2 square, and I can take infinite pairs of axes. बस condition ये है कि out of these two axes one must necessarily pass through center of mass. So just to remind, this theorem of parallel axis cannot be applied to any two parallel axes. No, it cannot. Out of those two parallel axes, one must pass through the center of mass of the object. If you have an object and if you have two parallel axes, neither of them passing through the center of mass, then you cannot apply this. Uh, theorem of parallel axis. So just to remind ourselves that these two or three or four or n moment of inertia are always passing through the center of mass, I will write this is equal to, okay,
Yes, sir.
आया समझ में? हाँ, बाकी लोग को समझ में आया? Should I draw another axis? So the parallel axis theorem is applicable for an infinite pair of axes, provided that you are able to answer 3 questions. Yeah, and I'll write it here. So parallel axis theorem to be applied if number 1, the 2 axes are parallel to each other. Number 2, one axis passes through center of mass. Number 3, distance between the 2 parallel axes is known. If the answer to all these 3 questions is yes, then you can apply the parallel axis theorem. Okay? ठीक है? ये आया सबको समझ में? Can we start with the application part now? So first question that we
एक
will
मिनट
हाँ
स्लाइड पे जाएं।
हाँ क्या चाहिए बच्चा? ये वाला?
एक मिनट पिछले वाली स्लाइड पे।
इससे पिछले वाले पे? इसी पे कि इससे
नहीं सर,
पिछले
ये
वाले? हाँ, ले लो स्क्रीनशॉट, लिख लो इसको, राइट इट डाउन, राइट इट डाउन.
हो गया सर।
Okay. So question number 1, the answer you know already. Question number 1, the answer you know already. Find the moment of inertia. Find the moment of inertia of thin rod of mass m, length L, about axis O dash. हाँ, बात आंसर आपको पहले से मालूम है. A dash, O dash नहीं लिखूंगा, A dash लिख देता हूँ. So the answer you know already, right? ml square by 3. You know the answer. But I want you to apply the parallel axis theorem and confirm. Apply the parallel axis theorem and confirm.
Yes, sir.
आ रहा है ना?
हाँ सर.
तो ये हमारा सेंटर ऑफ मास वाला एक्सिस है. Let me call this O dash. So I O dash is equal to ml square by 12. H is equal to L by 2. Are the 2 axes parallel? Yes, they are. Does one of the axes pass through the center of mass? Yes, it does. Do I know the distance between the 2 axes? Yes, I do. So now I can apply IAA dash is equal to IOO dash plus ml square. This is ml square by 12 plus m into L square by 4, which is equal to ml square by 3. ठीक है? Okay. Next. क्या इक्वेट करोगे? HIU क्या लिख रहा है? Find the MOI of solid sphere about any tangent H or I ओ ओ डैश इक्वेट क्यों कर रहा है भाई? इक्वेट करने के बाद थोड़ी ना बोला। हाँ बात बिल्कुल सही। माइनस नहीं हो सकता है ना दीक्षा? cannot be minus, right? You cannot have negative mass. You cannot have negative moment of inertia. अरे अरे क्या हो गया भाई? ये हमारा sphere है. This axis is about. So what is the purpose of this? What is the purpose of this theorem? The purpose of this theorem is that if I want to find the moment of inertia of the solid sphere about this axis, then I am not going to बिल्कुल सही. Then I am not going to carry out integration. Integration बिल्कुल सही. अगर मैं इंटीग्रेशन करना शुरू करूंगा तो मेरी हालत खराब हो जाएगी. वैसे ही इंटीग्रेशन में जो है it is always dicey. So I say that look, I know the moment of inertia about the axis O dash. Okay, नहीं बेटा गलत है आयुष. I know the moment of inertia about O dash. हाँ अनीश बिल्कुल सही. And I want to find the moment of inertia about the axis A dash. Right? And the moment I visualize the fact that the two are parallel, I must begin to suspect that the parallel axis theorem may be applicable here. But before I must make sure that not only are the two axes parallel to each other, but one of the axes is passing through center of mass. So one is passing through center of mass, and I also know the distance between the two axes. नहीं खुशी बेटा गलत किया थोड़ा सा. I O dash is equal to मैंने गलत लिख दिया. I A dash is equal to I O dash plus mh square, right? And this is R, so this must be h, so this must be equal to 2 by 5 mr square plus mr square, which is equal to 7 by 5 mr square. So in one step, I am getting the moment of inertia about the rim of a sphere, solid sphere, about the tangent of a solid sphere. Whereas through integration, it would have been endless calculations that I would have had to do to find the moment of inertia. जो लोग नहीं कर पाए समझ में आया? खुशी समझ में आया ये कैसे किया? Okay. Anybody who is having doubts here, please ask. O dash tangent नहीं हो सकता है यहाँ पे. एक जो O dash axis होगी, that will always pass through the center of mass of the object. जो center of mass वाली axis है plus mx square. This is also the proof of the fact that any axis passing through the center of mass of an object will have the lowest moment of inertia as compared to any other parallel axis. So if I have a set of infinite parallel axes, one passes through the center of mass of the object, then it is guaranteed that the moment of inertia of the object about that particular axis passing through the center of mass will be minimum, will be least. Okay, आगे बढ़ रहे हैं भाई, आगे बढ़ रहे हैं. Question number 3. अब इसमें थोड़ा सोच के करना पड़ेगा. This is definitely not a one step. This is definitely not a one step question. In fact, this is not a question at all. This is part of the standard table of results. जो हमने standard table देखा था, जिसमें हमने रिंग, डिस्क, hollow sphere, solid sphere का हमने निकाला था. अब हम ये ऑब्जेक्ट का भी मोमेंट ऑफ इनर्शिया वर्कआउट करेंगे एंड विल ऐड इट टू दैट standard table. Moment of inertia of a rectangular sheet, mass m, length l, breadth b, about an axis passing through the center and perpendicular to the plane of sheet. So basically we have a rectangular sheet like so. This is the axis. And this is the breadth B. Thickness is 0. I mean, for all practical purposes, thickness is 0. If you really want, you can take the thickness to be T or something, but it will cancel out. हाँ बहुत बढ़िया आयुष, yes, that is the correct answer. So I'll give you guys a hint. See, this rectangular sheet is made up of infinitely many thin rods, out of which I can say that at a distance of x and having a width of dx, this is one rod. Now, for this one rod, I know the moment of inertia about the midpoint. Right? I have already knowledge about the moment of inertia of a thin rod, about an axis passing through its center of mass. What I did not know up till now was that what is the moment of inertia of the green thin rod about an axis which is the blue axis. Yellow axis का तो मालूम था, blue axis का नहीं मालूम. हाँ, हम वर्कआउट कर सकते थे thin rod के लिए. We could have worked out the moment of inertia about the blue axis by using summation mr square, integration of mr square. But now we have a better way. Now we have an easier way. So work out the moment of inertia of the green rod about the yellow axis, then use the theorem of parallel axis to find the moment of inertia of the green rod about the blue axis. And now we need to find the moment of inertias of all the rods about the blue axis. Since you have found the moment of inertia of one element about the blue axis, all that remains is to carry out an integration, a summation, to find out the total moment of inertia of the rectangular sheet about the blue axis. आया समझ में जो मैंने बोला? Please try this out. हाँ, अच्छा. हाँ, सही है शोभा, बिल्कुल सही. बिल्कुल सही आ रहे हैं. Yes. बिल्कुल सही प्रतीक्षा. Yes. So Ti is equal to the moment of inertia. What if we had an axis which is passing through the sheet? नहीं समझ में आया मेरे को. I don't think I understood. So फिर से बताओ. Y of हाँ sure. बिल्कुल सही. अच्छा हो गया. हाँ अभी वो उस पे भी आते हैं. That is उस पे भी आएंगे अभी. We'll come to that. हाँ हाँ अभी आते हैं अभी आते हैं. अभी आते हैं. We'll come to that. अभी आते हैं उसी पे. पहले इसको एप्लीकेशन से. So about u axis will be equal to dm into length square by 12 plus dm into x square. What have I done? I have applied the theorem of parallel axis. This is the moment of inertia of the green rod about the yellow axis. And this is the parallel axis theorem. यहाँ पे मैंने एक्सिस को x डिस्टेंस से शिफ्ट कर दिया. दूसरे एक्सिस के अबाउट मोमेंट ऑफ इनर्शिया निकाला. So the net moment of inertia will be equal to integral of dm into b square by 12 plus integral of dm into x square. dm will be sigma multiplied by the area of the green strip that we have drawn, which will be equal to b dx multiplied by x square. And this will go from, you can write this straight 0 to m, and you can write this from minus L by 2 plus L by 2. Right? Where sigma, remember, sigma is equal to m by LB, mass upon area. So since here पहले वाले इंटीग्रल में केवल m ही वेरिएबल है तो सीधा m के टर्म्स में कर दिया. mb स्क्वायर बाय 12 प्लस ml स्क्वायर बाय 12 ये आएगा हमारा मोमेंट ऑफ इनर्शिया. Okay? सबने लिख लिया है. Therefore, what is moment of inertia of square plate about an axis passing through center. बिल्कुल सही. Perpendicular to I will be equal to okay. Just one question. Find moment of inertia of two thin rods stuck together as shown about an axis passing through center of mass and perpendicular to the plane of the rods. So this is rod 1, this is rod 2. Right? Both have mass m, length l. नहीं पाऊँ गलत आंसर. नहीं गलत आंसर है. नहीं पाऊँ गलत. नहीं आयुष गलत. नहीं पार रॉन्ग क्या हो गया भाई नहीं गलत है प्रतीक्षा ना आशुतोष रॉन्ग हाँ तो वेरी गुड क्वेश्चन गुड so where is the axis we have one thin rod which is located like this and then we have the other thin rod located like this and they are asking us for the moment of inertia about an axis which is passing through the center of mass of the system. First of all, you have to find where is the center of mass of the system. If this is the x-axis, this is the y-axis. This surely must be the center of mass of the first rod. This must be the center of mass of the second rod. बिल्कुल सही prediction. Yes. So this is having a coordinate of 0 minus L by 2. This is minus L by 2 comma 0. Therefore, surely the moment of inertia, the center of mass of the system must be here, having a coordinates of minus L by 4 comma minus L by 4. And the axis must be here only, perpendicular to the plane of the paper. ये आया समझ में तुलिका एक्सिस कहाँ है now try to find it you only have to find it for one rod and then you can just use the fact that moment of inertia they add up symmetry है ना यहाँ पे you just multiply that by 2 can't we find it about one of the rod and use parallel x yes we can yes no बच्चा minus L by 4 this is 0 comma minus L by 4 okay so let me try this moment of inertia of one rod about its own center of mass be equal to ml square by 12 right हाँ नहीं बिल्कुल सही तो कर रहा है तो अब क्या गलती है हाँ बात वेरी गुड yes so I need to simply now shift the moment of inertia of the rod about this axis do I know this distance of course I know this distance so I will have MOI of one rod about the system CY IAA dash is equal to ICUM plus M into this distance will be equal to how much? Basically, it is half the diagonal of a square of side L by 2, right? This should be L by 2 root 2, which is equal to ml square by 12 plus ml square by 8. Therefore, net moment of inertia is simply twice, which is equal to ml square by 6 plus ml square by 4, which is equal to कितना आएगा कितना आएगा लिखा था कितना आएगा 5 ml square
सर कोई तो एक रॉड पे एक्सेस नहीं ले सकते क्या?
हाँ वहाँ केयरफुल रहना पड़ेगा. So what if I don't want to do this? What if I want to say that look, I know that the moment of inertia about this axis, ये जो मैंने red से बनाया है, moment of inertia of the system about the origin will be equal to 2 ml square by 3. Why? क्यों होगा ऐसा? क्यों होगा ऐसा? ml square by 3 plus ml square by 3. Moment of inertia of a rod about an axis passing through one end वाला formula लगा दिया. Now here is the catch. You know the moment of inertia about this axis, but you want to find the moment of inertia about this axis, right? Know about this axis, want to find about this axis. Are the two axes parallel? First question. Are these two axes parallel? First question. Second question. Does one of the axes pass through center of mass? Does one of the axes pass through center of mass? But which one? Which one passes through the center of mass? Which one passes through the center of mass? The unknown one. The unknown one. जो हमें निकालना है. So in this case, IAA dash is equal to IOO dash plus mx square में we know the value of this and we know the value of this, but we don't know the value of this. So let me write this down. So this guy will be equal to 2 ml square by 3 is equal to IOO dash plus 2m now. Very careful, mass of the system multiplied by the perpendicular multiplied by the distance between the two axes, which is the same as before, L by 2 root 2 whole square. So I get 2 ml square by 3 is equal to IOO dash plus ml square by 4. So IOO dash is equal to 2 ml square by 3 minus ml square by 4, which is equal to how much? Which is equal to how much? Which is equal to how much?
5 ml square by 12.
आया ना अभी? Same answer. Right. हाँ अभी इसमें हमने बस ये एक्सिस के अबाउट मोमेंट ऑफ इनर्शिया हमें मालूम है 2 ml स्क्वायर बाई 3 है। ये एक्सिस के अबाउट मोमेंट ऑफ इनर्शिया में निकालना है। अब इस पूरे कंबाइंड मास का जो सेंटर ऑफ मास है वो यहाँ पे लाई करता है। तो आई ए डैश इज इक्वल टू आई ओ डैश प्लस एम एक्स स्क्वायर। आई ए डैश हमें मालूम है, जो मोमेंट ऑफ इनर्शिया सेंटर ऑफ मास के अबाउट वाला नहीं है वो हमें मालूम है, और एच भी हमें मालूम है, लेकिन जो मोमेंट ऑफ इनर्शिया सेंटर ऑफ मास के एक्सिस के अबाउट है वो हमें नहीं मालूम। तो मैं ए डैश आई ए डैश की वैल्यू रख दी, एम की वैल्यू रख दी, एच की वैल्यू रख दी। सो लेट मी जस्ट इसको भी मैं हाईलाइट कर दूं। ये एम की वैल्यू रखी, एच की वैल्यू, and then simply I find I O dash, which is coming out to be the same. So there is one more theorem that is there, and I'll discuss that now. So I'm going to change the slide. Okay, please take a screenshot. There is one more theorem, and this time it is called the theorem of perpendicular axis. Okay? But there is a catch here. The catch is that this is only applicable for planar objects. It is only applicable for objects which don't have a volume, which at most exist in a plane. Okay, valid for nothing else. You cannot apply it on a sphere. You cannot apply it on a cylinder. You cannot apply it on anything which has volume. So, if this is the x, y, and z axis, and if this is the planar object, okay, so this object is existing in the xy plane. In fact, I think I'll make the xy plane horizontal. So this is the planar object existing in the xy plane. So this is the x-axis, this is the y-axis, this is the z-axis. So if I take any patch of this object and I say that, look, the x coordinate of this object is xi and the y coordinate of this object is yi, then what is the moment of inertia of the object about x-axis? What is the moment of inertia of the object about the y-axis? Well, about the x-axis, the moment of inertia is summation mi mIyi square. Can you see? Can you see the moment of inertia of the object about x-axis is summation of mIyi square. I hope everybody can see this.
सर
This
आपने
is
एक्सेस गलत लेबल किए थे
huh?
सर एक्स आपने मतलब ये आउट ऑफ द प्लेन वाले को मार्क किया है
क्या फर्क पड़ता है? फर्क क्या पड़ता है?
फिर फर्क नहीं पड़ता वो बस मतलब परपेंडिकुलर डिस्टेंस फिर एक्स आई हो जाएगा ना
नहीं बे, एक्स आई ये डिस्टेंस होएगी ना, वाई
अच्छा
आई
हाँ
ये
सर सॉरी
डिस्टेंस। हाँ, मुझे भी पहले लग रहा था, बट फिर मेरे को याद आया कि नहीं, गलत। ये है वाई आई और ये है एक्स आई। And what will be the moment of inertia about the y-axis? Summation of mixi square. Now, if I add the two, what will I get? Let's see if I add the two, what do I get? So ix plus iy is equal to summation mi into xi square plus yi square. But what is xi square plus yi square? What is xi square plus yi square? Xi square plus yi square is this distance. Xi square plus yi square is this distance. This is x square plus y square. It is the perpendicular distance from the z-axis. So it turns out that Iz is equal to Ix plus Iy. This is the theorem of perpendicular axis. Okay, I'll put it in layman's words. If you have a planar object, okay, if you have a planar object, then if you choose the axis x and y to be in the plane of the object, if you choose the axis x and y axis to be in the plane of the object, and if you choose the z axis to be perpendicular to the plane of the object, then the sum of moment of inertia about the x and y axis will be equal to the sum will be equal to the moment of inertia about the z axis. Okay. आया समझ में? Please write this down. Of course, it would be an icing on the cake if the object is symmetrical and it turns out that Ix and Iy are equal. If Ix and Iy are equal, then Iz is simply twice the moment of inertia about the x or the y axis. Okay? So I'm going to change the slide now. Find the MOI, moment of inertia, of a disk about a tangent as shown. हाँ मतलब एक्स वाई जेड एक्सिस तो तरीका ऐसे ही ड्रॉ करेंगे ना that things will meet at the origin. अच्छा, you are saying is it necessary that they should meet at the center of the object? Very good question. No. Very good question. No, it is not necessary. So I can have a two-dimensional object like this, and I can set up my x, y, z axis here, and still I would get the same answer. So the perpendicular axis theorem would still hold. Okay. Very good question. Now the question that I'm going to give you, the question that I've written down, is going to require a simultaneous application. Simultaneous का मतलब दोनों लगाना पड़ेगा एक साथ नहीं, एक के बाद एक, of the parallel and perpendicular axis theorem. हाँ बिल्कुल सही बात, सही बात. अनीश सोच ले एक बार, think about it. I think कुछ गड़बड़ हुआ है. नहीं प्रतीक्षा. नहीं आयुष. Okay, see. I know the moment of inertia of an axis which is passing through the disk. नहीं, नहीं, no. आश्रय, बिल्कुल सही है. So I know the moment of inertia of the disk about an axis passing through the red dot perpendicular to the plane. Now since this is this, okay, since this is a disk, I know that it is a planar object, and therefore if I say that this is the x-axis and if I I say that this is the y-axis, then I know that ix plus iy will be equal to iz. नहीं अभी भी गलत, थोड़ा सा गलत है, right? I know this. I also notice that there is a symmetry here, and this symmetry tells me that ix and iy will be equal. एडिशन गलत किया गया, मतलब एक फैक्टर गलत आ रहा है. So this tells me, नहीं सुना गलत. This tells me, नहीं आ रही गलत. This tells me that iz is equal to twice of ix or iy. So iy is equal to iz divided by 2. But iz is equal to, remember, mr square by 2. So this must be equal to mr square by 4. Right? Now, are the two axes parallel to each other? Y-axis and the a dash axis? Yes, they are. Does one axis pass through the center of mass? Yes, it does. So we get half friction of center. So we get IA dash is equal to ICUM plus m into the distance between the two axes whole square. mr square by 4 plus mr square is equal to 5 mr square by 4. Okay. So I think I'll stop here. I'll give you lots of time to digest this. Please start with HC Verma now. Any problem of moment of inertia you can solve now. Any problem where they are asking you to find moment of inertia you can solve. So please search for problems of finding moment of inertia in HCV in the booklet which is given and try to solve. Next class also we will be discussing moment of inertia for a little while, at least for 1 hour. And then we will move on to other concepts in this chapter. ठीक है? I'll stop here. कोई slide किसी का miss हुआ तो बता दो. अच्छा, final exam है क्या? हाँ, बिल्कुल. I think you'll get a couple of days, 3 days, 4 days. I think you will. चलो, okay guys.